Let's continue our study of methods by improving the craps game we wrote earlier. Here's the problem statement. We're going to improve the program to play a modified version of craps. The user is going to roll 2 6-sided die. They lose if the sum of the digits is 7 or 11. That's called craps. They win if the sum of the digits is 2, 3, or 12. And they roll again if the sum of the digits is 4, 5, 6, 8, 9, or 10. Now, there are a couple of shortcomings of our previous code. One is repeated code. Now, you may not remember repeating code, but if you think about it, we did a bunch of copy and pasting. And when you do copy and paste, that's a warning that you could use a method. So our first method will be for rolling the die. Let's think about what the signature should look like. First off, the method name should be roll die. Notice that we can't say roll dice. Dice is actually plural. It means there are 2 or more of them. And we can't return 2 things from a method, so we can't roll dice. We can only roll 1 die. As far as the parameters, well, there are no parameters. And the return type will be an int. Now, clearly this is going to be a one-line method, and you might wonder whether a one-line method actually improves anything. Well, it does. For one thing, it does information hiding. So it conceals the details of how the random number is generated from people who use the method. And that's a good thing because it leaves their concentration free to think about other things. The other thing that's improved by having a one-line method is consistency. So let's say, for example, there was a mistake in our code, which, by the way, there isn't. At that point, we could find that mistake in one copy of the code and forget that we need to change it in the other copy of the code. This happens especially if you're maintaining somebody else's code when you didn't know that it was copied in the first place. But even when you're the one who copied it, it's easy to forget. So that's a place where you do get an improvement even though the code doesn't get shorter. So better and shorter aren't always the same thing with programming. Let's go to Eclipse. This is the calculation that we're going to conceal. So I'm going to copy that. I'm going to go down below the method and create a new method, public static int roll die, and paste in the code. Now we don't actually need to save this to a local variable. So I'll just put a return statement there. Now we're going to call the code up here by doing roll die. It had no parameters, so it doesn't need any arguments. And we'll do the same thing here. Of course, we want to run our code immediately to make sure it's correct. So we've gotten 1s, 3s, 2, 4, 5, 6. Hey, we got them all in our first try. That's neat, so we don't have to do a lot of work. Now the next thing we need to do is improve this method. A method that returns random choices between 1 and 6 inclusive may not be used too often, unless of course you're writing a whole bunch of programs that use dice. But on the other hand, suppose we have a method that returned random choices between start and end. That method might be used a lot more. So to make that method, we're going to add parameters. They'll be called int start and int end, of course. Now we're going to need to repeat our boundary analysis to make sure we're doing the right thing. So again, math.random goes between 0 and 1, but 1 is exclusive, so the largest number is 0.99999. If we multiply by end minus start, which seems like a natural thing because it's sort of the distance between end and start, we'll get 0 when we multiply by 0, but we'll get end minus start minus 1 plus 0.99999. Oh, that looks like we're headed for trouble. When we cast that to an int, the 0 will work fine, but the other number, the 0.99999, will give us n minus start minus 1. If we add start to that, the 0 ends up in the right place, but what we end up with at the other end is n minus 1. Now, you might think we should add start plus 1 at the end, but if we do that, notice we'll mess up our start position then, although it will fix the end position. So where the trouble started was actually in that second step, when we multiplied by n minus start. So that's where we need to fix it. So we take the same random numbers and now multiply by n minus start plus 1. When you have n minus start plus 1, that goes to n minus start plus 0.99999. This is when you're multiplying by 0.99999. Now when we cast it to an int, we'll get 0 to n minus start, and when we add start, we'll go from start to end. So this looks like a good solution. Let's go and write our method. So we're back in Eclipse, and we're going to go down to our method. Now we're going to need to change the name of our method because our method is now more general than it was. So let's say generate random in range and go between int start and int end. So now what we're going to return, math.random times end minus start plus 1. Now I'm going to show that as 1.0 because this multiplication between math.random and n minus start plus 1, we want that to be a double. It will be, of course, naturally, but this makes it more clear that that was our intention to have it a double, that it wasn't just a happy accident. So now we're going to go back to our program and generate random in range from 1 to 6 and generate random in range from 1 to 6. And of course we want to check and make sure our program is working again. So we've got 2, 3, and 4. That's kind of nice, but we haven't seen 1, 5, or 6. There are 5s and 1s. No 6s yet. There's a 6. Good. We've gotten all of our values. That's really, with random numbers, as close as we can get to knowing that things are working. And notice we haven't gotten any illegal values, so that's good too. So we've done our first test, and that's to try it on the dice program that we adapted. But we might want to try some different ranges inside the program. We could do it with one die only, or we could do with both. We could, for example, generate numbers between 1 and 5, and 2 and 4, and 3 and 4, and 3 and 3. Now we might want to think about that last one, about whether that should even work or not. Well, between 3 and 3, we would always get 3s out. I guess that makes sense, so why not see if our method works there? So let's go and do some more testing. So first we're going to generate between 1 and 5, and 1 and 5. Running the program again. I see 2, 3, 4. There's a 5. And there's a 1. So we were very lucky our first time we got it all. Now let's go between 2 and 5. So I see 3, 4, 5. Let's see if we got a 2 anywhere. And there are 2s. Good work. So now we were going to look at 3 and 4. See what values we got there. So we're expecting to just see 3s and 4s. And we have a 3 and a 4. Now we were wondering about this 3 and 3. Seems like maybe it should work. Well, we're getting lots and lots of 3s out, which I guess is what that should do. So that looks good. Let's stop that from running. And let's think about some ideas we could have for a second method. The logic part of this has gotten fairly long and complicated. Now, part of the reason for that is that we don't have very sophisticated logic operators yet. And so that will improve a little bit on its own. But it is the kind of detail that could be shuffled off to a method and hidden from the main program. So let's create a method that returns one of 3 things. It could return lost, it could return 1, and it could return play again. Now notice that I've put those names in all caps. That's one of the ways you can see that I'm thinking about those as constants. Notice we couldn't have it be a Boolean, because with a Boolean we can't get 3 choices, we can only get 2. So we're going to need some integers. The method signature will look like this: int determine craps result, and it will take int roll as a parameter. Let's go down and create the signature for the method first. Public static int determine craps result from a roll. So there's our signature. We could put return 0 in there if the complaint from Eclipse bothers you, but instead let's just go and grab our code that we want to encapsulate. And copy it in. Now, we're going to have to modify this code a little bit because we're no longer returning from the program. So at this point, we may not want to do our system out print lines here. We may want to do those in the main program. I think that makes a lot more sense. So here we should return when. Now let's go and create those constants so that we don't have any problems using them. Final int when equals 1. Final int lose equals 0. And final int play again equals 2. Now we're going to have to pass those to the program too. So we'll do int win, int lose, int play again. So here we're returning win. Here we'll return win. Notice these are not in caps now because these are the parameters we're using. And we weren't going to put the system out print lines here. So we'll return play again. Whoops. Play again looks like that. This one we probably want to copy so we can paste. And I know just a few minutes ago I said that when you're copying and pasting, you're probably doing something wrong. You're doing something that could be in a method, and that's true. Now this one, we're going to return lose. Here, we're returning roll again, or play again. Here, we're returning play again. There's play again. Here we'll return lose. And as I recall, 12 actually wins, not loses. Now I see one other thing that I could do in this code. Notice that if the value of roll is not between 2 and 12, this method isn't going to return anything. That's not good. But it's particularly not good because we don't expect that case to occur. When you have a case that you don't expect to occur, I like to actually put a little else statement in there to catch it in case it does recur. So I'll do system out print line. This is an unexpected case. Now we still have to return something from this case, so let's return lose, on the theory that people will notice more if they lose when they should do something else than anything else. It's important that you give people feedback that a case you didn't expect to occur is actually occurring. Now let's check our parameters again. Roll is first, then win, lose, play again. So here we're going to do determine craps result, roll, win, lose, play again. Now we're going to have to store that value somewhere, so we're going to need another variable for that. And if you think about it, now three things can happen: winning, losing, playing again. Well, what does that mean about our while statement? Now we can see what it should be. While result is not equal to play. While result is equal to play again. Now, to do that, we're going to have to move the declaration above, because remember, when something's declared inside the while loop, you can't use it in the condition of the while loop. And we need to initialize it correctly so we get into the loop the first time. So that's cleaned up that funny little infinite loop thing that we had to put in earlier. So notice we're getting a better structured program. Also notice that our main program is in a good target range for length. Remember, between 10 and 20 lines of code is about right for a main program. So let's think what happens here. We get our result back. The last thing we need to do is to give the user some feedback. So if result is win, system out print line, you won. Else if result equals lose, system out print line, you lost. Else, now we could do this one of two ways. We could say else if result equals play again, system out print line play again, and then have another else that we don't expect to be executed. Either one of these are just fine. Let's do the shorter one. System out print line play again. So there we go. Let's put in some more comments to make sure people understand our code. Report the result of the turn to the user. The logic for craps is in the determine craps result method. So notice we have a comment, a few lines of code, a white space, a comment, a few lines of code, a white space. That's a good, healthy pattern for software, for making your code easy to read. Well, we certainly need to run this program and make sure it's working. Oh, look what we forgot to take out. We're just getting 3s. That program's going to run for a really long time. So remember, this was supposed to go between 1 and 6. And 1 and 6. That is a risk with using your code, by the way, to do random testing, is that you can leave some garbage in your code. As you see, it's not very hard to fix as long as you remember to test adequately at the end. So 5 and 6, that's an 11. You're supposed to lose with an 11, so that looks good. 3 and 1, 5 and 2, so we still need to see a 4 rolled. With a 4, you're supposed to play again. With a 7, you're supposed to lose, so those are looking good. 6 and 6, that's a win. Remember, that was the hard one to find the first time. 2 and 3, that's a 5, play again. 1 and 1 is a 2, which you won. I don't know about you, but I'm wishing that we had that little table we had before to make sure that we were catching all of our test data. So there's a 7 and a loss. There's a 2 and a win. 2 and 3 is 5. 3 and 1 is 4, which is a play again. 3 and 2. Well, without our little table, we can't be really sure that we got them all, but it does feel like things are working correctly. So notice our main program now is a much more manageable length. We have a couple of methods. One, which is probably not going to be reused much, it's just good for craps. But we also have created this generate random in range that we could reuse in a lot of other programs. So notice we're getting a little bit more value for our software engineering. I do see one thing we could improve in the documentation, and that's to make sure that people know that start and end are inclusive. So let's say we generate a random number between start and end, both inclusive. Those are good things to document so you don't have to figure out which way it was the next time you look back at the program. So keep programming.